Hello again, algebra students. We are moving on now that we've practiced simplifying radicals and practiced multiplying radicals. And when we were multiplying radicals, remember there were multiple ways that we could do that. Sometimes we'd put it all together into one radical. Sometimes we'd make separate trees. Today we're going to be dividing radicals. And we're going to have options again. So I'm going to try my best to show you all the different options that you have. Again, always looking for the easiest way to solve these problems. So in this first problem that I have, square root of 25 over the square root of 4. Now, when we multiplied radicals, we said we could just multiply them both. In this one, technically, we could make this one big fraction. It doesn't really help us because 25 over 4 is not a nice whole number answer. And that didn't really help us at all. So instead of doing that, I would say, oh, these are both perfect squares. In fact, both problems on the screen right now, all perfect squares. So the square root of 25, that's just 5. And the square root of 4 is just 2. And stop there. Don't give me 2.5. Don't give me 2.5. I don't need decimals. This is a simplified fraction. Yes, it's improper, but we're okay with improper fractions. In the second problem, again, also both perfect squares. We just said the square root of 25 for the denominator, that's just going to be 5. The square root of 49 is 7, because 7 times 7 is 49. And again, stop there. Don't give me 1 2/5. Don't change it to 1.4. Just 7 over 5. Done. One thing you need to know about simplifying radicals when we have division is that we can't technically leave radicals in the denominator. It's just not quite finished if we have that. Every problem we're going to do today, that shouldn't be a problem if you finish the problem, okay? In this next problem, the 3 that we have on the top part of the fraction, this one right here, it's a regular number, it's just going to be outside. The square root of 100, right, and the 100 and the 9, I wouldn't mess around with that at all. The square root of 100 is just 10, and the square root of 9 is just 3. Now, in fact, I wouldn't even multiply those numerator numbers together to get a 30. I would just say, oh, I can cancel that 3 with that 3. My answer is just 10. If you did multiply, you would get 30 over 3, which is, by the way, look at that, 10. In the next problem, square root of 64 over 8 times the square root of 16. Don't think that you can cancel the 8 with the 64, because the 64 is in a square root right now. However, 64 is a perfect square. Square root of 64 is just 8. On the bottom, this 8 was on the outside. It's going to stay on the outside. The square root of 16, that's not 8, that's 4. And similar to the last problem, I wouldn't bother making that 8 over 32 and then simplifying. The 8 on the top and the 8 on the bottom can simplify. That's just going to be 1/4 for my answer. Now, 108, 3, neither one of those are perfect squares. So I do need to find a way to simplify this. I can make this one big fraction. That's supposed to be a 108. Because they're both in radicals, I could just put the whole thing into one big radical. Now, 108 is divisible by 3. I can just simplify that number inside the radical. Didn't get rid of the radical yet. 108 divided by 3, that's just 36. And the square root of 36 is just 6. Be careful, it's not the square root of 6, it's just a regular 6, because 6 times 6 is 36. In the next problem, again, please be careful. Do not think that you can cancel the regular 7 with the square root of 7. They don't match. If one's in a radical and one's not, they're not the same kind of thing. However, the 63 and the 7, I could, let me show you how you can write this. I could write this as just, notice that 7 in the front, I didn't make it like 7 over 1. You can, but you know that that 7 in the front is really just that 7 over 1 right there, so it's just 7. And 63 divided by 7, that's nice. That's 9, still in the radical. So the square root of 9 is just 3. So my answer here is going to be 21. An option that you have in a problem like this, with both of those radicals, I could just simplify them, kind of considering like the one big fraction bar, or I could just say, well, what if I would divide both of these by 7? This would be a 1. This would be a 9. So then I would have 7 times the square root of 9, which is what I have right here. And then on the bottom, I would have the square root of 1, which is just 1. And I don't need a denominator of 1. So there's different ways to look at that division when we're simplifying these. Here, again, please don't think that you can just say, oh, well, 4 times 6 is 24, so that cancels that out. Because it doesn't. The 4 is not in a square root sign. It's not in a radical. However, I could take the two radicals and say, well, let's divide them both by 6. This would be a 1. This would be a 4. So that's still inside my radical. That's going to be the square root of 4 over. I have a 4 on the outside. Oh, a square root of 1, that's just 1. It doesn't do anything. In fact, I can just ignore that. And the square root of 4 is 2. I'll keep my same denominator. And 2 over 4 is just 1/2. We are doing a lot of work with just simplifying fractions today. We have to be careful about if things are in radicals or not, but it's just simplifying fractions. In the next problem, the square root of 32 and the square root of 2. Again, I could absolutely say, well, let's just divide both of those. Since they're both in radicals, let's divide them both by 2. This will be a 1. That'll be 16. Again, still in the radical. I know it doesn't really look like it's in the radical, but I didn't do anything to get rid of the radical. Now, I would even say that I don't think that there's even a reason to write down the rad 1. I can on this one last problem, but I don't usually tend to write that one down. The square root of 16, that's just 4. 8 is just going to be 8 down there, and then 4 over 8 again is 1/2. I know how much everybody loves fractions. Must be really happy today. This next problem is one that I could see tricking some students. Now, if you listen to me very carefully at the beginning of this lesson, I said, we can't leave any radicals in the denominator. So I know 100 is a perfect square. I could make that into a 10, but then I would have 10, a regular 10, over rad 2. That's not okay. So instead of doing that, even though that 100 is so tempting, I am just going to divide both of these by 2. So that'll be a 1, and this will be 50. So I really have rad 50 over rad 1. Well, rad 1 is just 1. This is really just the square root of 50. And now think back to what we've been doing with simplifying radicals. Square root of 50 is not done. I have to split that up. Let's make a tree. So the 5s are going to break out. The rad 2 is going to be left over. In the second problem here, this time I'm going to say, you know what, those 13s, they're both not in radicals. They're both regular numbers. 13 over 13, I could just divide them both by 13 or do some canceling. Those are just gone. Next, I want you to consider the square root of 121. Because 121 is actually a perfect square. The square root of 121 is 11. Because if I would make a tree, I would have 11 times 11, circle. There it is, it breaks out. 65, let me do that down here. The square root of 65, well, it ends with a 5. So I know that I could divide by 5 for sure. It's going to be 5 times 13. Oh, there's no pairs. Can't do anything extra with that. Nothing breaks out. So those two are just going to go back together, make it into the square root of 65, and there's my answer. That one's done. Today's worksheet. It's a radical division worksheet. So I just did a whole bunch of examples with lots of different ways to look at this. So be careful there. If you are checking in with the answer key that's in Schoology, you might do it one way and the answer key might do it a different way. If you get the same answer, it's all good. There's a formative in Schoology, and if you need any help, let me know.